Lion Tamer early detection demonstration in a lithium-ion battery rack. Hello, my name is Oscar Salazar. I'm from the Latin America Xtralis Honeywell team. We're here today at the Vertiv Learning Center in Mexico City. And we're doing a test of our lithium-ion battery detection system called Lion Tamer. Here, we have a UPS of 480 volts. And on this side, a battery rack with lithium-ion batteries, with 16 batteries of 67 amp hours. Now we will monitor these batteries with Lion Tamer, an off-gas monitor with gas sensors. Inside, we have the Lion Tamer controller installed. The inputs on the controller use RJ45 Ethernet cables. The cables connect directly to the sensors. There are two types of cables. Blue is for the reference sensors, just like the one over here, which is used to measure any false positive in the space not caused by the battery in the environment, so we don't get a false alarm. The black cable is for the detector monitoring the battery racks to the monitor sensors from each rack. Down here, we have a serial cable that's connected to our PC to monitor real-time sensor readings and monitor any changes when a gas bump test is performed. Here, we have the digital outputs from the system where you can connect output relays, and all of this is connected to the battery management system monitoring the lithium-ion batteries to let the BMS know when to shut down power on the batteries and stop charging. This means to disconnect the charge of the lithium-ion batteries in case of an emergency. Lithium-ion batteries charge quickly, they have a long life, and they're light in weight. But if the batteries are abused, they have a high probability of catching fire. The abuse happens due to overcharging or overheating. This could be because of a mechanical, electrical, or thermal fact, which would cause a liquid electrolyte inside the battery to change to a gas. Then the internal pressure inside the battery will increase and breach the separator, which will cause thermal runaway or fire. Really hard to stop in a system like the one we have here. But with Lion Tamer sensors mounted here, we can detect these off gases and shut down power to prevent fire or thermal runaway. Just like the main sensor we have here, and we have another one up here to compare, like if they were two cabinets. Okay, so here we have a cable connected to the battery management system. And this is the window with the system to measure how it behaves in real time and see when it disconnects. We're going to test this system with this diethyl carbonate bottle, which is one of the solvents contained in lithium-ion battery electrolyte. I'm just going to shake it a little bit. This is an authorized test bottle to test Lion Tamer sensors. I shake the bottle so it generates gas vapors, and I'm going to squeeze the bottle to release the gas vapor so the sensors can detect it. Once detected, the controller will send a message to shut down the charging. Let's see. What we're going to see here is a fault indicator at the beginning, and then an automatic disconnection. Here, we can see how Lion Tamer interfaced with the Vertiv VMS system. On this side, we can see on this PC the sensors and the alarms that were generated. We can see that sensors 1 and 2 are active because of the alarm that we just generated. Here we can see how they stay triggered and be able to track them. On this side, we have this red sign, which indicates that something happened in the rack VMS. And here we can see an automatic alarm called eStop, which stands for emergency stop. So we can see through Lion Tamer and the VMS, we can generate and see alarms simultaneously. Reference sensor. What is a reference sensor? They're sensors, like the one here, located at the physical entrance, like doors or air conditioning vents, and they're used to detect volatile organic compounds or other gases that may trigger a false positive. In other words, these sensors will prevent false alarms from similar gases not related to the lithium-ion batteries, and notify the controller to prevent a false positive. Let's do the test here. We spray at it a little bit, and we can see how sensor 1 is now activated. Here you can see the actual status as active. So when that sensor is activated, let's spray some gases again here. We expect nothing to happen since this is the reference sensor. This means the batteries will continue to charge and the system will avoid a false alarm. If we wait a little more, you'll see this sensor will not be activated.
Xtralis, the sooner you know, the safer you are.